Okay, today we're going to look at solving exponential and logarithmic equations using what we have learned about log and exponential properties. So you can read through the verbiage that's on the page, but we're going to do a couple practice problems because this is a property we have already learned. So we're going to start with the examples that are at the bottom of my screen, right here. If I want to solve for x, we can make 10 and 1,000 have the same base. So we're going to rewrite 10 or 100 as 10 squared, and then to the 7x plus 1, and this is going to equal 10 cubed to the 1,000 to the 3x minus 2. Then I can use my power rules, and when I have a power raised to the power, I multiply. So this is 10 to the 14x plus 2 equals 10 to the 9x minus 6. Remember, you distribute to both things in the power. And now we can use that one-to-one property because the bases are the same. So if the bases are the same, then we know that 14x plus 2 has to equal 9x minus 6. I'm going to minus the 9x over and get 5x. And then I'm going to minus the 2 the other way, equals negative 8. Divide by 5, and you should get that x equals negative 5/8. Let's try the next one. The base that 81 and 1/3 have in common is 3. 3 to the 4th is 81. 3 minus x. And then 1/3 we can write as 3 to the negative 1 power to the 5x minus 6. So we get 3 to the 12 minus 4x equals 3 to the negative 5x plus 6. Again, because the bases are exactly the same, we can invoke that one-to-one property. 12 minus 4x equals negative 5x plus 6. I'm going to add the 5x over, making 1x over here. Subtract the 12 the other way, negative 6. So x equals negative 6. Okay, again, you can read through this verbiage, but I'm just going to give you a tip that I've always used. If the form that you're in is not working, then convert your form. So what I mean is, in this problem, 4 to the x equals 11, I cannot rewrite 4 and 11 with the same base. So the form that I'm in right now is exponential form, and it's not really helping me. So I'm going to convert to logarithmic form to see if that will help me. So I'm going to start with my base. Remember, I always make my sushi towards the equal sign. So I can rewrite this in the equivalent logarithmic form as log base 4, 11 equals x. And now look, magically the x is all by itself. The only thing you have to do is take this to this piece right here to the change of base. So you can put it in the scientific calculator. So we get log, remember the base goes on the bottom. So log 11, or you can use ln, but I always write log. Log of 4 equals x. When you type that in the calculator, this should be the answer that you get out. Okay, so now we're going to try. So let's start at the beginning. The form we're in for number 4 right here is not helpful, so I'm going to make that loop. I'm going to convert, so it's going to be log base 2 of 5 equals x. So log 5 over log 2 should equal x. Good rule of thumb is to round to 3 decimal places unless you were told otherwise. So let's round to 3 decimal places. Once you put that in the calculator, you should get x is about 2.322 when you round to 2 decimal places. The next one, same idea. So we get log base 7 of 15 equals the 9x. This one we have to convert and then we have to divide by 9. So we have log base 15, log of 15 divided by log of 7, and then this has to be divided by 9, and that's going to equal my x. Again, I'm going to round to 3 decimal places. You should get the x is about 0.154. The last one is slightly different. Before you make that little swoosh, you do have to isolate the exponential or the log. So I'm going to minus the 4. And you subtract the 4, we get 5. Now you can do this, make your swoosh. It's going to be log base 10 of 5 equals 3x. And we don't have to even write log base 10 of 5. We just know it's log 5 because the common base is implied. And then we just have to divide this by 3. So this is much easier to enter in our calculators. Much, much easier. You should get that x is about 0.233. Okay, again, we're going to go back to this one-to-one property. We have log base 5 and equals a log base 5, which implies that this 4x minus 7 has to equal my x plus 5. So 4x minus 7 has to equal x plus 5. Subtract the x over, 3x equals, add the 7 the other way, and then x equals 4. Okay, again, I'm going to let you read this verbiage, but instead of converting, you can do what's called exponentiate, or raise both sides to the same power. So let me go in here real quick. We start out with this statement, this statement right here. And so what they do is they raise both sides with a base of 4. So see how the 4 and the 4, and then what's in my power is my equation. What's going to happen here is right here, the exponential and the log of base 4 will undo each other. And then 4 to the third is simply 64. Another really easy way to do it is, again, if it's not helpful in the form it's in, change the form. So if you live log base 4 of 5x minus 1 equals 3, that's not helping me, so make your swoosh becomes 4 to the third equals 5x minus 1. That's the same thing that they have right here. 4 to the third is 64. 5x minus 1, add the 1 over, 65 equals 5x. X equals 13. So the processes are exactly the same. You could do whatever way makes more sense to your brain. Okay, so let's try a couple times. This one, the form it's in is not helping me, so I'm going to convert. So you get 2 to the 5th power equals x minus 6. 2 to the 5th is 32, so 32 equals x minus 6. Add 32 over, so 38 equals x. Now this one's a little bit different. I have 2 logarithms, so before you swoosh or convert forms, I have to condense these 2 together. Because they are adding, I can multiply. So I can rewrite this as log 5x times x minus 1 equals 2. Remember, there's a hiding base down here of a 10. So now that I go to make my swoosh, like this, I get 10 squared equals 5x times x minus 1. Okay, 10 squared is 100. I'm going to distribute and get 5x squared minus 5x. And I am now going to solve. This is a quadratic, so 0 equals 5x squared minus 5x minus 100. I'm going to divide everything, both sides, by a 5. Or you can factor out a 5. It's the same thing. So when you do that, you get 0 equals x squared minus x minus 20. 0 equals, we're going to factor x minus 5, x plus 4, x equals 5, and x equals a negative 4. Now, there's some verbiage we didn't talk about. Our answers might be extraneous. It is a good practice to always take your answers and plug them back in, but in particular with logarithms. Here's why. If you take this and plug it back in right here, or even right here, we have a problem. So here's what that says. That piece would say log, when I plug the negative 4 in, 4 times 5 is negative 20. I would have log of negative 20. Now let's think about this for a second. This is log base 10, and it equals question mark. Now if I solve this like this, what this is saying is 10 to some power equals a negative 20. That's not possible. There is no power that I can place on a 10 that will change it from becoming a positive to a negative. Even if you make that exponent, the question mark, a negative number, that just flips the 10 to the denominator and makes it become a fraction. So again, there is no power, the question mark, that I can put there to make the positive 10 become a negative. So this one right here is extraneous. Now if I plug the 5 in, you get log of 25, and that's okay. So what you're really looking for, good practice, is right here. Log base b of a. This a thing, when you plug it back in, is never negative. Otherwise, your answer would have to be extraneous. So in this problem, my answer is only 5. So if you get an answer, it's good practice to plug it back in, first of all. Second of all, make sure that a is not negative. Okay, so I'm going to let you pause the video, and I'm going to let you try this one, and then we can do it together and check. Okay, so I condensed the two logs and made it log base 4 of x plus 12 times x. Then I swooshed and made the log become an exponential form. So 4 to the third is 64, and then I multiplied in the x to make x squared plus 12. Quadratic, so it equals 0, so I subtracted the 64 over, and then factored, so I got x equals negative 16 and 4. And when I plug in the negative 16, you get log base 4 of negative 16 plus 12. Well, that's log base 4 of a negative 4. Remember, this thing here can't be negative, so this one is extraneous. I just do want to clarify something. It is not always the negative answer that is extraneous. It's when you plug it back in, that piece right there, the of piece, the log base 4 of whatever, cannot be a negative. So if I write it again, look at it on the other screen. Log base b of a cannot be a negative. Okay, so let's practice solving. If at any point in time it's too fast, you can pause the video and copy it down and listen, but we've done a lot of these, so it might be a little bit quicker than the other screens. Letter A is in exponential form. It's not helping me, so I'm going to convert. I get log base e of 72 equals x, which log base e is just ln. So ln 72 equals x, and x equals approximately 3 decimal places unless we're told otherwise, 4.277. On the next one, I'm going to divide by the 3 first. So 2 to the x equals 14. Then I'm going to convert. So log base 2 of 14 equals x. Log of 14 over log of 2 will equal x, and x will equal approximately 3.807. On C, you have to add the 3 over first, so you get 4e to the 3x equals 5. Then divide by 4. So now we have e to the 3x equals 5/4 or 1.25. Then convert to log. So log base e of 1.25 equals 3x. Log base e is ln. And then we divide by 3. And then we can just type that in our calculator. So you should get that x is approximately 0.074. Okay, this one's a little bit trickier, so subtract the 7 first. So negative 2e to the x equals a negative 2, then divide by the negative 2 on both sides. So e to the x equals 1. Please don't use a calculator for this one. If you can't see the answer yet, I'm going to get log base e of 1 equals x, which is ln of 1 equals x. Something to a magic power equals 1. Well, that means x equals 0. Because if you raise anything besides 0 to the 0th power, you will get 1. Okay, so let's keep using what we've learned. So on this first, we need to add the 4 first. So you have 2 times 3 to the 2t minus 5 equals 15. Divide by 2, so 3 to the 2t minus 5 equals 15 over 2, which is 7.5. Either way, 15 over 2 is fine as well. Then I'm going to convert forms because this is not doing me any good right now. So I get log base 3 of 7.5 equals 2t minus 5. We have to enter this in our calculator using change of base, so log of 7.5 over log of 3 will equal 2t minus 5. And then to this we have to add 5 and divide by 2. So it's log 7.5 over log of 3. Again, you could use ln plus 5. And then take this whole quantity and divide by 2. This should equals t, which is going to be about 3.417. So go ahead and try the next one, pause the video, and then make sure you get the same answer. So I added the 13 over, divided by 5, converted to logarithmic form, used change of base, subtracted the 3 and divided by negative 1, and you should have got that x is approximately negative 1.498. Okay, these ones are a little bit new and different, so let's try these. Okay, we're going to use what's called u substitution. So we're going to let u equal e to the x, which means that u squared equals e to the x squared, which is the same thing as e to the 2x. So I can rewrite this original equation. E to the 2x is called u squared minus 3u plus 2 equals 0. We're going to factor. So u minus 2 minus 1. So we get u equals 2 and u equals 1. But we didn't have u, we had e's. So we have to replace them back in. E to the x equals 2. E to the x equals 1. And then neither one of those forms are helping me, so I'm going to convert to logarithmic. The beauty is the base is e, so these are going to be ln's. So this is going to be ln of 2 equals x, and ln of 1 equals x. Well, anything to the 0th power is 1. So we know here x is 0. And then for the other one, we just type it in our calculator. And when you type in your calculator to 3 decimals, x is about 0.693. So go ahead and try the other one, pause the video, and then come back and see if you get the same answer. So you should have done the u substitution like we did in the previous problem. Factored, you should get that u equals 5 and u equals negative 1, and then replace the e to the x back in. Now this one right here, that's a problem, because e to some power is going to be a negative. Remember, e is 2.71 blah, 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 blah. There's no magical x that I can raise this number 2 to make it become a negative. So this is extraneous. And we're just going to type the other one in the calculator. So for the other one, x is 1.609. Ta-da! Okay, the next page. This is now becoming a little repetitive in review, but we got this. So on this one, the base here is e. So e squared is 3x. You can just type e squared in your calculator and then e to the second. And then you're just going to type this in your calculator and do e squared, then divide by 3. 2.463. On the next problem, there's only 2 logs, nothing to condense. Same base, so that screams one-to-one property that 5x minus 1 has to equal x plus 7. So 4x equals 8 and x equals 2. Just checking if I plug the 2 in here, neither one of those statements become negative, so it's good to go. Okay. These problems, I'm going to subtract the 5 over first, so I get 2 ln x equals negative 1. Ln x equals negative 1/2. Remember there's an e here, so I get e to the negative 1/2 equals x. You just type that in your calculator. X is about 0.607. Okay, add the negative 2 over. So 2 ln 3x equals 19. Divide by 2, so ln of 3x equals 19 over 2, which is 9.5. This is an e here, so e to the 9.5 equals 3x, and then divide by 3, divide by 3. So x is going to be equal to approximately 4,453.24. On the next 2 pages, there are some practice problems, and the key is posted for you to check yourself.